Hi people, this is the video segment for homework number 8. Okay, now this type of problem that you see on the right top corner, actually these came from section 3.1, but I didn't have room to include it in the previous homework. So these two problems, 82 and 84, are actually from 3.1. And let's go ahead and do, let's say 82 first. Okay, let me delete this so that I have more room. Delete that. All right. Let's take a look at 82 first. It says that you have a oops, just a second. Okay. It says you have a car and the wheel has radius 11 inches. So here's the wheel of the car. Okay. And it has 11-inch radius. So this radius is 11 inches. Okay. And it rotates at 600 RPM. So it rotates like this at 600 RPM, and RPM stands for round per minute. What it's asking is what is the speed of the car. Now we know that the speed of the car is given by velocity, or I think that's what the variable is that they're using, V equal to R omega. This is radius of the wheel, and this is angular velocity in radians per second. Well, actually, it really doesn't matter. Whatever you put here, the answer that's going to come is going to be the velocity is going to be in terms of the unit of this. For example, in this case, if the radius is inches, and if this is radians per second, this answer is going to be inches per second. So it's going to be inch per second. Okay. On the other hand, if you, for example, make this thing radians per minute, then this becomes inch per minute. Okay. If this is hours, this becomes inch per hour. So you decide. Since the since the speed up in terms of rounds per minute was given in terms of minute, this is what I'm going. The middle one is what I'm going to be using. So here's what I'm going to use. Let me erase all of this. Okay, so this was given to me in inches. No problem. I'll be use inches. This was given to me as round per minute, so I'm going to convert it to radians per minute. So the answer I get for V is going to be inch per minute. Okay, let's go plug it in. All right. This number is 11. This number, 600 rounds per minute, so it's going to be 600. Each round is 2 pi radians. So omega in radians per minute is going to be that number. Okay. So the answer that we get here, if you put it in your calculator, is going to be speed in inch per minute. Let me go put it in my calculator. So 11. Where's my calculator? Just 1 second. Okay, free version. All right, let me clear all the stuff. So it's going to be 11 times 600 divided by 2 pi. Oh, I'm sorry, multiplied by 2 pi, not divided. Multiplied by 2 pi. 2 times pi. Right there. Enter. So this number that you see here is the speed of the car is inch per minute. Now, let's go ahead and find out what the conversion factors are. So, for example, if you go, see for a second, if we go to Google right here, and I typed in inch per mile, okay, so 1 mile is that many inches, okay. So if you want to, or if you want to know, for example, yeah, 1 mile is 63360 inches. So if I go here and I want to convert this number that I got, what did I get here? Let me write it down. 41469, 41469, okay, inch per minute. If I want to know how many miles this is, I divide that 41469. I divided by that number that I saw uh, on uh, on Chrome, which is 63360, 63360. So this is miles per minute, but since you're asked to find it in terms of miles per hour, you have to multiply it by 60. So this is miles per hour. Let's go ahead and do that. So this is divided by uh, what was that 63360, and then we have to multiply it by 60 to turn it into hours. 60, and this is 39.267 miles. So 39.267. 39.2. This is correct, but it's going to be inch per minute. And so is this. This is correct, and it's going to be the answer in the unit that was given to you, or was asked for, miles per hour. All right. So let's go do the problem number 84. Let me get rid of the stuff that I don't want here. Okay. We'll erase this. We'll erase that. Let's do all of these. Okay. Problem number 84. A truck with here's a truck. The diameter of the wheel is 48 inches, so the radius is 24 inches. Okay, and it's traveling at 50 miles per hour, and this is going at 50. In other words, v is equal to 50 miles per hour. What we like to know is what is the angular velocity, angular speed. What is omega? Now the formula that we got is v equal to r times omega. So if we put, for example, for this 24 inches, omega must be that's just the thing we want to find. Okay. Now, here, this is the speed. It says is 50 miles per hour. So, since I'm using the inches here, I have to convert this into inch per hour. Okay, so for example, 50 times. Remember the conversion factor was 3. I think it was 3. Can't remember. Second. 63360. 63360. Okay. Now, if I find omega out of this relationship, uh, it's going to be the unit of it is going to be radians per hour. Okay. And there's nothing wrong with it. It's just that what we are asked to do is radians per minute. Okay. So this speed, this number here, right now, it is inches per hour. To turn it into inches per minute, so that I don't do the conversion again, I'm going to divide by 60 because there's 60 minutes in 1 hour. Okay. Now let's find omega here. Omega is going to be 50 times 63360 divided by 60 times 24, and this is going to be rad per minute. Remember, this is not the answer. This is not the answer to the question because, oh yeah, rad per minute. That's right. So that's fine. Let's go ahead and do this. So let's go here. It is man, I keep forgetting these things. 50 times 63360, and it is divided by 24. Was it 24? 60 times 24 divided by 60 times 24, and this is going to be radians per minute, 222200. So this is going to be 2200, obviously rad per minute. Now in part B, it says how many revolutions. In other words, what is the speed in RPM? So omega in RPM, which means rev per minute, is equal to this number that we got divided by 2 pi, because each round is 2 pi radians, and this is going to be the answer to part B. So let's take that number divided by 2, divided by pi, Now, I also want to point out to some of you that may not see that you could have done this thing by answer divided by parentheses 2 times pi. Since I did not want to enclose the parentheses, since I did not want to do it like that, I divided by 2 and then I divided by pi. And this is 350 RPM. 350 RPM. This is 350 RPM. I rounded it to whole numbers right there. So we have taken care of these two problems, or these two problems came from section 3.1. You have to you know these. Okay, good. So let me close this. And I'm going to open up my not this one, yeah, my homework right there. Okay, we just took care of that. Let me erase this. All right, let's go ahead and do these problems. These are coming from 3.2 now. What does it say? Find the exact value. This is number 3. Say find the exact with 6 trigonometric ratios of the angle. Okay, so let's see now. Sine theta. Sine theta is opposite over hypotenuse. So you look at opposite to theta is 4 over 5. And just leave it like this. You can write it as 0.8, but we don't have to. Cosine of theta is adjacent over hypotenuse. Adjacent is 3 over 5. Tan theta, well, while we're here, we might as well do cosine, secant and cosecant. So secant of theta is 1 over cosine, which is 5 over 3. And cosecant of theta is equal to 1 over sine, that is 5 over 4. Tangent of theta is opposite over adjacent. So this is going to be opposite to theta. For problem 3 is 4. Adjacent is 3. And of course, cotangent of theta is 1 over that. So it's going to be 3 over 4. Okay? So that takes care of number 4. Let me erase these things. Okay, that's good. Erase these things. Erase that. Let's do number 3. Number 3. Okay. Same thing. So sine theta is opposite over hypotenuse, 7 over 25. Cos theta is adjacent over hypotenuse. This is 24 over 25. Obviously, cosecant theta is 1 over sine, which is 25 over 7. And secant theta is 1 over cosine, which is 25 over 24. Tangent of theta is opposite over adjacent. So that is 7 over 24. And cotangent of theta is obviously the reverse of this, or inverse of that, which is, let me write that, adjacent over opposite, which incidentally is 24 over 7. Okay, so that takes care of this problem. I'm gonna maybe I'll do one more problem and then we stop this video, do a second one. So let me close this. Let me start this thing again. So we just took care of these 2 problems. Let's do this one. We just took care of the top 2 boxes. Let's do this. Number 11, it says, okay, find the side labeled x, so find this, and state your answer rounded to 5 decimal point. Okay, so what we have to do is, here we're going to write as, for example, sine of theta is equal to opposite over hypotenuse, okay? Now sine of 30 degrees equal to opposite, I don't know what it is, x divided by 25. So x simply is equal to 25 sine of 30 degrees. Incidentally, these are angles that you should know. It's also pi over 6. Sine of pi over 6 or sine of 30 degrees is 1/2. So it's going to be 25 times 1/2, and this is 12.5 units, whatever it is. Now, if you don't remember these, you should. But if you don't remember it, you can always go and put it in your calculator. Sine of 30 degrees, make sure your calculator mode, if you're going to use 30 degrees, make sure your calculator mode in angle is on degrees. If you're using radians, make sure that your calculator mode is on radian, and then type pi over 6. Okay. Okay, so let's go and do this one. Number 12. There we are. This is hypotenuse that's missing. So, for example, we can say this is number 12. we can say cosine of 45 degrees is equal to adjacent over hypotenuse. Well, actually, let me use, the adjacent is here. This is not going to help me, so I'm going to change this thing to sine instead. And this obviously is going to be opposite, okay? So this is sine of 45 degrees equal to opposite. Where is it? Oh yeah, right here. You're doing this problem, right? Opposite over hypotenuse. So we have this number. This number you should know it by heart, √2/2, or you can put it in your calculator. And opposite is 12. Hypotenuse is what we do not know. So we have x equal to 12 times 2 over √2, okay? Or 24 over √2. Now we can go to our calculator. You can use a 24 over √2, or you could have used the sign directly. So I'm going to do 24 divided by √2. Now where's the root? Is right there. Second function, √2, 16.9. Well, the problem says use 5 digits, so it's going to be 16.97056. Let's see now. 16.97056, I think. Excuse me. I think that's what it was. 056, yeah. All right, so I'm going to stop. Maybe we have, yeah, I'm going to stop this thing and 17, 18, etc. I'm going to do it in different segments.